Hello everyone, welcome to my next video. This one is about how to measure current into a microprocessor. So for example, an Arduino Pro Mini. So how to measure current. So, in my situation, I'm using an Arduino Pro Mini. And it's a pretty good thing. It's 5 volts input, and I need to measure current into this thing. So again, there are different ways of doing it, but I find the easiest way is to use one of these. This is a ACS712 current sensor. So it's a Hall effect sensor basically, and it's made by a company called Allegro. It's an American company, and this particular one can measure up to 30 amps. So let's have a look. So unlike the voltage divider in the last video, this one works a little bit differently. I'll just see if I can focus in here. Yeah. In this one, you just feed it with basically it has 3 pins. There's one for VCC, which you supply 5 volts to it. There's out, which outputs up to 5 volts into your microprocessor. And there's ground, which obviously goes to ground. You've got a couple of capacitors here and a little LED and a resistor. But there's the Hall effect sensor there, or the Hall effect IC. And this is where you'd screw the terminals for the circuit you want to sense the current for. Okay, so there's the sensor I'm going to be using in this video, and there's my Arduino, which is going to read the result. So let's get started. So I'm going to start by bringing in my prototyping board. Let's get those out of the way for a minute. So there's my board. I'll plug. I need my UART thing as well. Plug the UART in here. Then I'll plug the Arduino in there. Okay. Put this there for a minute. So now I need a connection to 5 volts and ground. Now, I'll be able to get this through the USB port, so I'll just pull this out for a sec. Let's have a look at the pins. Yeah, the last one is ground. That one is ground. Oops. That one is ground. Put that. I'll leave that there for now. And let's see, VCC is the third one along. That one, right? So I'll put this back in. So then I'll put the ground into the ground rail. Put VCC 5 volts into the VCC rail. Okay, now I need to find the leads for these. So we've got ground, we've got data, and we've got VCC. So VCC goes to the +5 rail, ground goes to the ground rail, and this data pin goes to, let's say, A0. Not sure where A0 is. It's the 5th one. 1, 2, 3, 4, 5. This one. Okay, so we have everything connected now. Oops. Just knocked the camera there. Right, okay. We have everything connected. So far so good. So I just need to get my laptop now. Okay, time to do some easy coding. So to start with, int value, and down here serial.begin 9600, and down here we want value equals analog read A0, and down here we want serial.println value. Okay, analog read. Oops. Right. So, actually I will have to save that. So save that to measure current. Right. Now, I've got to check the connections here, so I'll just move this. Just check my connections are right. Yep, that's right, that's right. VCC to VCC, ground to ground. Okay, I'll plug this in. Just move this camera to here. Now I'll upload this. Done uploading. Right, let's get the serial console up. Okay, and it's coming out with all this. 548, it's coming out with that. Okay, so this 547, that represents half of the either end, basically. It's middle point, which means 0 volts. I know that because this ACS712 is bidirectional, so it can measure AC current, it can measure minus amps and plus amps, which doesn't really make sense on the face of it, but anyway, that's how it works. So what we need to do now is find the sensitivity of this device. So I've already found the documentation for this, and if I go down here, we can somewhere find the sensitivity. There we go. 0, 5, 20, 30. Right, this is the one for this particular model. It's a 30 amp one. So accuracy range current minus 30 amps to 30 amps. Sensitivity 66 millivolts per amp. 66 millivolts per amp. Okay, that's good. So with this thing being 66 millivolts per amp, what we could do with doing is converting this number here into volts. That will let us work or find out how much voltage we're getting, and we can then find out the amperage from that according to this sensitivity of 66 millivolts per amp. So let's do that now. So the first thing we need to do is get rid of this offset, basically. Let's do that first. So 547 seems to be the number coming through. So value equals that. Value equals value. Take away 547. Let's reflash that. Uploading. Done uploading. Okay, so now we're getting 0 or minus 1. That's okay. Next thing we need to do is convert whatever we get into a voltage. So that's the next thing we need to do. To be able to do this accurately, we really need to apply some sort of current onto the ACS712 now, so that we can monitor the changes and keep an eye on it and make sure we're doing things right. So I'm going to quickly wire something up that can supply us with some current. So here we go. So that's the ACS712 there, and I'm going to turn my power supply on. I've just moved these two closer together so you can see what's going on. Okay. Now, if I increase the current, you should notice the number increase. You see in the serial console. And you can see the number going higher and higher. 30, 50, 60. That number is representing the amount of current that's going through this sensor. 5 amps. Okay, so 5 amps is giving us 73 points out of 512. Okay, and then back down again. And then back up. Alright, so we are getting something meaningful. Now we have to work on this and find out, or we basically have to change it into volts. So we'll do this now. Let's get the calculator up. Um, 5 volts divided by 1023 is that huge number. Copy that. And in the code, const float VPP equals that number. Then we need another one actually. Float voltage. And here voltage equals voltage equals value multiplied by VPP. Then put that there. Let's reflash that. Done. Get the serial console up. 0.01 volts. So I'll increase the current now, and the voltage should go up. Okay, and that's 5 amps. Okay, so that's how many volts. Well, allegedly, that's how many volts are coming through from 5 amps. So I'll put that back down again now. Put it back up. Alright, so that's 360 millivolts. 360 millivolts. Now we read before that this unit shown 1 amp per 66 millivolts. So what we need to do now is put another field in here. Float current. The current equals voltage divided by 0.066. So the current equals the voltage divided by how many 66 millivolts are in it. So there's volts, hundreds of millivolts, tens of millivolts, units of millivolts. So that should be about right. Let's put that in there. Oops, and let's re-upload. Done uploading. Get the serial console back up. Alright. Now this figure now should be amperage. So I'll try and increase the amperage. Okay, it's saying 1.2 amps. I'll keep going up. Okay, according to my power supply, that's 2 amps, and this is reading 2.3. I'll keep going up. Okay, according to the power supply, that's 3 amps, and this is reading 3.3. The power supply is now saying that's 4 amps. And that's reading 4.4. And now a power supply is saying that's reading 5 amps. And this is saying 5.4. So one of these two devices is lying. I'm not sure which one. So what I'm going to do now is find out. Now I have my multimeter in the circuit to verify how much amperage is actually going through. Move this up. Oops, hang on a minute. Okay, let's try again. Okay. So the power supply is saying, well, 5 amps, and the little multimeter here is saying 5.06 is about the same really. Now the Arduino is sensing something slightly different. The Arduino is sensing. The Arduino is sensing this. 5.3. So we know it's not quite right there. So let's just go down to 0 again. Both meters are sensing 0. So we know there. That's a tiny little bit out, but okay. And then back up. Let's see what's happening here. Yeah, 5.4. Right. So the first thing we should do is take off that 0.07 or 0.15. So I'll do that now. So I'm just going to take a bit of a guess here. I'm going to take off maybe another 2 points. Let's say 550. And re-upload that. Okay, so it's now a little bit lower. Let's see what it does now. So I'll add the current into the circuit again. 2.5, 3, 4. Okay, that's 5 amps. So the multimeter says 5.05. The power supply says 4.97. And this says 5.18 or 11. So let's try a different amperage. Let's try 4 amps. Let's try 4 amps. Now that's 4 amps. Okay, and it's over by about 2 points. Let's try 3 amps. Okay, it's over by a few points. Let's try 2 amps. Okay, yeah. 1 amp. Oops, 1 amp. Okay, go back up to 2 amps. I think we get away with taking maybe a point off that. Let's re-upload. Done uploading. Okay. Let's add some more amperage again. So we've got there's 1 amp. Here's 2 amps. Here's 3 amps. Here's 4 amps. It's a bit fiddly actually. There's 4 amps, and finally there's 5 amps. So okay, it is sort of out a little bit. I could sort that out with that 0.066 figure there. I could alter that by a tiny fraction and probably get it right, but I don't think that's such a problem. So it's about 100 milliamps out in about 5 amps. So that's okay, I suppose. And there we go. So that's how to do it anyway. So you use the I use the ACS712. Simply give it 5 volts and attach ground. So we've got the ACS712, attach VCC to 5 volts, attach ground to ground, attach the data pin to an analog pin on the Arduino or whatever microprocessor you're using. Then here's the script. I'll just move that along so you can see it. And there we go, that's all there is to it. So thanks for watching, bye!